causes sound? Come over here. Start with you. What causes sound? Yeah, vibrations. Vibrations of an object. Through a medium. I'm going to be a little more specific here. So you have to have vibrations, so that's the starting part. It has to be caused by an object, and it has to go through something. Okay? So the simplest form of vibrations of sound are talking. So your vocal cords vibrate. They cause the air around it to vibrate, which is the medium. So it's vibration of an object, my throat, in a medium, the air. And the transfer of energy goes from there. So we talked about two types of waves, longitudinal and transverse waves. Which type is sound? This one's a little tricky if you've forgotten anything, which I'm sure nobody has. These type of waves where they're forwards and backwards vibrating, and they're just vibrating back and forth. So this is what the sound wave does. This is how we can see it, but this is what the sound wave is doing. That is a longitudinal wave. Okay, and number 3, what is pitch? Yeah, Mason.
I wrote the frequency of the sound.
Yeah. Good. Frequency of the sound. Get it. You take your headphones out. You take your headphones out. Thanks. All right. So what's the difference between a high-pitched sound and a low-pitched sound? So part of what we want to figure out today is what's actually different about all these different things. So I got 2 different tuning forks here. This one is 4,000 hertz. This one is 125. Okay? So here's what the 4,000 hertz one sounds like. Okay, you got a little squealy thing. There we go. There's 4,000 hertz. Here is 125. But it's actually much, much lower than that. You can really hear. It's actually really low. It's like, okay, that's my amazing voice right there. You're going to hear my amazing voice plenty of times. You're going to love it. Anyway, so there's this sound and this sound. So what's the difference between them? Well, obviously, their frequency is different, but specifically, high pitch has high frequency, low pitch has low frequency. I wanted to show this to you, but my demo's not working right now. I'm going to try to see if I can get it fixed, but I do not have time to fix it today. So we'll just talk about it. So low pitch is low frequency. So low frequency would be something like this. And again, they're longitudinal, so this is just easier way to draw them. That's not what they look like. And then higher pitch are higher frequencies. So something like this. Happen more often. Okay? What's the difference between a loud sound and a soft sound? So if I'm going to play the same thing 2 different ways, one's quiet and one's loud. The difference is how much it vibrates. So notice that no matter how hard I hit it, it vibrates at the exact same frequency. But how hard I hit it determines how loud it is. So amplitude, or the size of the wave, determines how loud it is. So what's the difference between a wave with a loud sound and a soft sound? So quiet is small amplitude. Which would look something like this. And loud would be a large amplitude, which would look something like this. Nolan, can sound go through liquids, gases, or solids as well as gases?
It goes through solids better than gas.
Good. So it does go through all three, and it goes best through solids, then through liquids, and then through gases. So, yes. And the order of how well it goes best through solids, then liquids, then gases. Now, you may be saying to yourself, Mr. B, I've never heard sound going through solids before. What do you mean sounds going through solids? You have heard sound go through solids before. Okay? Because I can shut the door and those sorry people on the hallway can still hear me. Because the sound can go through the solid door. The sound vibrates the door, and its door particles vibrate, which will then vibrate the particles on the other side and vibrate the air in the hallway. So sound does go through solids. If you've ever watched a Western movie before, right? There's a point in the movie where the hero puts his ear down to the railroad track and he's like, I hear that train a-coming. Anyway, that actually works. You can actually put your ear down to a railroad track and hear the sound of the railroad, the train, coming from further away than you would normally, because sound travels faster through the railroad track. It travels through liquids too. You know this. You've been in water before probably, and if you have, you hear things in the water. So you can hear sound going through it. The reason it doesn't sound right in the water is because your ear is supposed to hear air particles, not water particles. So your ear doesn't translate the sound from the water very well. But it does travel through solids, liquids, and gases, and it goes the fastest through solids, the slowest through gases. You're just used to gases. That's the only reason it seems like that's funny. Okay. I'm going to give you a minute to think about this one. And I'll give you a hint. Think about the definition of what sound might be from what we've talked about. So the question is, if a tree falls in a forest and no one is there to hear it, does it make a sound? Okay? So you've heard this before. Classic kind of conundrum type question. If a tree falls in the forest and no one's there to hear it, does it make a sound? Take a minute. See what you think the answer is. Just think about it from what we've talked about with sound. What do you think the answer is? So I'll give you about 30 seconds to a minute to think of what you think. All right. Number 7. Tree falls in the forest. No one's there to hear it. Does it make a sound? Okay. Let's see. Gabe, what do you think?
Yeah.
Yes, it does. And the reason why... Gabe, why do you think it does?
It doesn't have to be like received by anything.
Yeah. It has vibrations. Caused by an object. That can, not that they have to be, but they can be heard. That's all you need. You just need to be able to hear it. You can. It has to be able to vibrate an object and travel through a medium. It does. So just because you're not there doesn't mean it's not making the sound. So if a tree falls in the forest and no one's there to hear it, does it make a sound? The answer is yes. And all of your friends who want to complain and argue otherwise are wrong. Yeah.
What if life's a simulation? That's just
What if life's a simulation? Well, then sound is simulated, in which case it's still a real thing. So yes, even if it's a simulation.
I'll get you someday.
One of these days, okay. All right. In space, nobody can hear you scream. Why? Yeah, let's go with Zach. What do you think?
Is it because it's just empty space? There's
Yes.
no air,
Yes. There's no medium to vibrate.
Have you been taking a gap up there? How do you know?
What?
He hasn't even taken a gap of space yet. How does he know there's no air or gas?
I mean, you can tell without having to go and do something.
It's already been well established that there is no air.
$10, you're going to go and check. $10 won't get you on Elon Musk's space flight. All right. So there's no medium to vibrate. So in space, there's no air particles for you to vibrate if you're to talk or scream. And so if you were to do it in space, you wouldn't make a sound and no one could hear you even if you could. So there's no object to vibrate the space through. Yeah.
Do you believe in the Big Bang Theory? I just want to see.
That's a little different. Let's just say the Big Bang Theory as a scientific theory is very, very solid. So yes.
I was just
But the Big Bang Theory is not what you think it is. I'll leave it as that. What you think the Big Bang Theory is not what the Big Bang Theory is. The Big Bang Theory is you think is there's a huge explosion and things explode and things. That's not what the Big Bang Theory is. Yeah.
So, okay, but the body also, like, could a sound bounce off of you? Like,
Yeah, but it would have to go through something first to get to you in the first place.
okay, and the other question is, if somebody's like in space, if somebody's like 2 meters away from you,
No, still wouldn't be able to. They could be 1 inch away. If there's no medium to vibrate, it doesn't matter how close you are, you're not going to hear it. The one exception to this would be if they were to put their hand on your vocal cords, they could feel them vibrate. And in theory, you could pick up something from that. But you make the sound with how you move your mouth. So you could feel my vibrations, but you wouldn't be able to tell what I'm saying. But that would be the extent of it. Yeah. But besides, you wouldn't be if you went out without a spacesuit, you wouldn't be around much longer. So, but you wouldn't die instantly. You would have time to fix your mistake.
No, you would not.
Yeah, you would.
You would just be if you didn't have like a spacesuit.
Well, you can get back. You can get back in. You can get back in
What
real
you gonna
fast.
do? Like doggy paddle? Like aren't you just like?
Throw a shoe backwards, and then Newton's third law: every action is equal and opposite. So you take your boot off and you throw it and you go backwards. Yeah, there you go. All problems solved. All right.
Makes sense to me. I tried to visualize that, but it didn't make sense.
No. All right. Let's talk about natural frequencies, resonant frequencies, sound, all this sort of thing. Okay.